Okay, great, thanks. My name is Quercus Hamlin. I'm a geospatial analytics engineer at Airspacelink, and today I want to share how we're using cloud-optimized GeoTIFFs and other cloud infrastructure to support scalable on-demand drone solutions. So first, a word on Airspacelink and why we're doing what we're doing. Every few decades, over the past 150 years, there's been a major inflection point in the infrastructure industry, whether that's been vehicles, telephone, or highways. It's really changed how we do business and live our lives. We see drones as this next inflection point and a way to fuel human progress and good, whether that be delivering packages and taking cars off the road to reduce carbon emissions, or delivering organ transplants more efficiently. Today, our mission is to integrate drones safely into the federal airspace and communities at scale. I'm hearing someone else in the background here.
Okay, I think I got it.
Okay, thanks. So we have a variety of tools to do this, things that help both pilots, local governments, and the federal government. But today I want to share what we're doing for advanced solutions using our geospatial analytics. So we're doing this on ArcGIS Online and an Azure stack, making use of Azure functions, the serverless computing similar to AWS Lambda. And we're doing this in Python, Go, and JavaScript with a variety of open source geospatial tools. Since this is Cloud Native Day, I want to focus on what we're doing with COGs in particular. One thing that we see differentiating us from others in the market is our commitment to data sets, and particularly geospatial data. We've aggregated a repository of over 60 data sets in our AirHub Insights lab, and these are ranging from COGs stored on Azure and vectors stored in ArcGIS Online. One thing that is an issue sometimes with data and having so much data is how can you get it to all talk to each other and be harmonized, be able to use it in analytics. And that's where we've turned to H3, which is Uber's hex grid available at multiple resolutions. So we're able to, on the fly, aggregate all of this data and have it in a format that we can do things like risk analysis and routing to minimize risks or site suitability. I would do a demo, but with the Lightning format, I was just afraid of tempting fate with technology. So these both took just a few seconds to aggregate, and there aren't any hexagons stored anywhere. It's all on the fly, pulling from those data sets in the cloud. The other tool that I wanted to talk about that I've recently developed is our Elevation API, and this relies heavily on COGs and how easy they are to query at scale. So elevation and altitude are a tricky thing in the drone industry. Drones are regulated based on their height above ground level, which means both knowing what ground level is and agreeing on it with both drones and other aircraft and models. So we've turned to having DMs stored as COGs and are able to retrieve those and do the necessary datum conversions via rasterio in an Azure function. So whether the measurement is coming from a GPS system or a digital elevation model, and soon we'll have barometric pressure, we're able to convert it and do this on the fly. So this can be used for things like deconfliction, whether that's between drones and other drones or drones and airplanes, as well as compliance monitoring. So continuously making sure that drones are not flying too high as this information comes back and forth. The other thing that we're doing with this is route planning, a way to both use 2- and 3-dimensional visualizations to help operators know what terrain challenges they might run into and what they need to do to stay compliant with regulations. And so as that ground level changes, the altitude you need to fly also changes. COGs are key to this. The ability to query small pieces of large rasters in the cloud environment allows us to do this in a telemetry format. So drones can continuously just ping this service and we return that value and conversion in less than a second to do this. That is what I wanted to share with you all today. Thank you. I've really enjoyed this event and I'm excited to see what we can also do with things like XAR and GeoParquet. Thank you.
Thanks so much, Quercus. That was great. Yeah, I mean, I'm a back-end developer, so I'm usually interested in like the details of like the formats and all that. But seeing these end-to-end applications, like it's like, oh, like this is how this stuff is actually used, which is really, really cool to see. So thank you.